Hello, this is Mr. Rupp, and today I am going to cover Pre-Algebra 9-3, representing linear functions. Okay, so grab your math journal, and let's get to it. In this video, we're continuing our exploration of functions, and we're going to be focusing on linear functions, representing them. Okay, now remember, a function can be represented in words, or in a table, a function table, or with a graph, all right, or as a set of ordered pairs of coordinates. Let us start with example 1 here, which is basically just a function. School supplies. The school store sells book covers for $2 each and notebooks for $1. And Tony wants to buy some of each. The cost of X number of book covers and Y number of notebooks is 2X plus Y. Tony has $5 to spend, so 2X plus Y equals 5. All right, so graph 2X plus Y to find out how many book covers and how many notebooks Tony can buy. Now, the first thing to realize is that there isn't just one solution to this problem. 2X plus Y is equal to 5. You've got two variables. Well, what happens if Tony doesn't buy any book covers? X is 0. Well, how many does Y? What does Y equal then? Y equals 5, right? So she would end up buying 5 notebooks for $1 each. Okay, all right. Let's solve for one of the variables and get this equation into a more normal form. Okay, a simplified form. So we're going to write down the original equation here. 2x plus y is equal to 5. Okay, so what we're going to do is we're going to move the x's over to the left side. So we're going to go minus 2x and we're going to go minus 2x on the right hand side. Now remember, we do minus because for this 2x on the left side, there's nothing in front of it. It means it's positive. So to undo a positive, we do subtraction. All right, so these cancel and we're left with y equals the 5 minus 2x. That's the equation that we're going to use to work on our function table down here. Okay, y is equal to 5 minus 2x. All right, and this is our function table. So our input value is going to be x. This is the function rule. Our output value is y. And then here are going to be our coordinate pairs, x comma y. All right, so like I said in the example, if x was 0, okay, then this is 5 minus 2 times 0, or just 5. So our ordered pair then is 0 for x and 5 for y. Okay, now let's say, I think right up here we're going to write x equals book covers. And that's $2 each. And y is equal to notebooks. And that's $1 each. So let's say she wants to buy at least one book cover. Well, then we have 5 minus 2 times 1. So y then would be 3. So here we have 1 comma 3. So she can buy one book cover and then 3 notebooks. All right, well, let's say she wants to buy 2 book covers. All right, so 5 minus 2 times 2 is 5 minus 4, which is 1. So here we have 2 comma 1. So she can buy 2 book covers and then 1 notebook. All right, well, let's just say that she decides she wants to buy 3 book covers. So we have 5 minus 2 times 3. That's 5 minus 6. And that means y is negative 1. So here we have 3 comma negative 1. So here is this function over here listed as a function table, okay? function table. These are the coordinate pairs. All right. The first pair that we're graphing is 0, 5. Okay, so we go over here and we go over 0 on the x-axis. Well, that's the origin right here. That's where you don't go anywhere on the x. We go up to 5. Just like that. Now we're going to graph 1, 3. So on our graph, we come over positive 1, and then we go up 1, 2, 3, right there. And now we're going to plot 2, 1. All right, so we come over to our graph and we go over 2 for the x, and we go up 1 for y. And our last point was 3, -1. All right, so let's find out where that puts us. 3, -1 here. Over here we go 1, 2, 3, and then we go down 1. Well, this is our first point, 0, 5, right here. And I guess I could write that in there. 0, 5. Here is 1, 3. Here is 2, 1. And then down here we have 3, -1. The 3, -1 is special because x is the number of book covers and y is the number of notebooks. Well, y in our last example here is a -1. Can you have a negative number of book covers? No. This is not part of our function. All right, our function over here, we don't include that. We don't include anything that has a negative y because you can't buy a negative amount of notebooks, and you also can't buy a negative amount of book covers. That's why it starts here at x equals 0. You can buy none, in which case you can, if you buy no book covers at all, then you have $5 left to spend on notebooks, and they're $1 each. So you can get 5 of them. That's what this means right here. But you can't spend negative dollars to get a negative book cover, okay? So it starts at 5, 0, 5. It goes to 1, 3, and 2, 1. Our domain then for this function, right, is this squiggly line. The domain is 0, 1, 2. Now what's the range? The range is 1, 3, and 5. Those are the y values. Just going in order, not necessarily in matched order. Otherwise it would be 5, 3, 1. Moving on to example 2. That'll be on page 476. And they want you to graph this equation. Y is equal to x plus 2. So what we're going to do is we're going to select 4 values of x and put them down into our function table and get corresponding y values out. And then we're going to take it over to our plot, our graph, and we're going to graph them and see what kind of line that we get. Our function rule is x plus 2. Our input variable is x. Our output is y. And then here we have our coordinate pairs, x, y. All right, so now this is a fairly easy example, just like example 1 was. And they make it easy so that you can tell immediately if you're off track or you've made a mistake, okay? But don't use this easiness to shortcut the process, because you'll get into equations, I assure you, that will not be easy. And if you have shortcut the process here, in other words, you don't know how to actually move forward without jumping to the end, you're going to be lost. So pay attention. And do everything that I'm doing here when you do your homework, okay? All right. Now, does it matter which values of x you pick? No, but considering that our graph over here goes from -5 to +5, I would put it in that range somewhere, okay? Now, we can make negative numbers on this too. So how about we do this? We go x equal -2. So we have -2 plus 2, therefore y is what? 0. Okay, we'll fill in the xy pairs here at the end. What about x equal -1? Well, if x is -1 plus 2, then that makes y equal to 1. If x is 0, then 0 plus 2, y is 2. If x is 1, 1 plus 2, y is 3. And if x is 2, 2 plus 2, y is 4. Okay, let's go back here and put in our ordered pairs. So when x is -2, y is 0. When x is -1, y is 1. When x is 0, y is 2. When x is 1, y is 3. And when x is 2, y is 4. All right, now let's go and we'll plot these points on our graph. Okay, so the first point says x equal -2. So here's -2, and y is 0. So that means that this point is right on the x-axis. The next point says when x is -1, y is a +1. So that means our point's right there. The next point says that when x is 0, then y is a +2, right there. When x is 1, y is a +3, right there. And when x is 2, y is a +4. One thing to note is right here, where the graph crosses the x-axis, that's where y is equal to 0. That's called the solution of the equation. So this guy is called the solution. All right. Good. So we have a function that's defined as a table, as a set of ordered pairs, and as a graph. You can also have a function defined as words, like our example 1. Now that brings us to the definition of what a linear function is, okay? So a linear function is a function whose graph of the solutions forms a straight line. Let's look at some of how you would represent a linear function. All right, so in words, here's an example. The value of y is 1 less than the corresponding value of x. All right, that is a function represented in words. How about a function represented as an equation? Well, that function that you just saw there, that you just read, the value of y is means equals 1 less than. Now, in this case, you'd want to write 1 less than x, and that is not true. English, this is the one case in English where English is really messing with you. In your head, 1 less than the corresponding value of x, you know what that means, but that's not what it says. Okay? It is not 1 minus x. It is x minus 1. That is a trap that almost everyone falls into. So be aware of it. It is the only case where this is true. All right. So how about being represented as ordered pairs? Well, I'll tell you what. Before we get to that, why don't we do the function represented as a table, and then we can pick out our ordered pairs from there. So here is a table really quickly. All right, so when x is 0, x minus 1, y is negative 1. When x is 1, 1 minus 1 is 0. When x is 2, 2 minus 1 is 1. When x is 3, 3 minus 1 is 2. Like I said, very simple. So then back over here then, ordered pairs would be 0, negative 1. 1, 0. 2, 1. 3, 2. All right. As a graph, you would have x is 0, y is negative 1. And when x is 1, y is 0. When x is 2, y would be 1. And when x is 3, y would be 2. All right. This is a graph, and we'll connect these dots. With a line, okay? So that means here then y is equal to x minus 1. That's that line. So these are 1, 2, 3, 4, 5 ways of representing a function. Words, equation, table, ordered pairs, and a graph. If you have any questions about this, please email me in regular email with questions, and I will get you an answer as soon as I can. Thank you very much for watching.